Is it possible to produce solar cells from recycled silicon? Well, let's find out what we are doing about it in the Reselex project. The purifying silicon produced by the Norwegian University of Science and Technology, obtained from revalorized wastes, presented in the previous video, was received by the partner CEA in ingot shape. In the Reselex project, the goal of CEA is to assess the use of this alternative silicon feedstock for the growth of Czochralski ingots for photovoltaic solar cell applications. After receiving this silicon ingot, further characterizations were conducted at CEA, such as resistivity and conductivity measurements. In addition, the impurity analysis of 25 elements was conducted by glow discharge mass spectrometry. The results confirmed that this recycled silicon reached a level of purity of 99.999% on the major part of the ingot. This high purity part of the ingot was accepted for being used in CEA's Czochralski furnace as feedstock to grow a new ingot, suitable for solar cell applications. In order to reach the necessary specifications for solar cells application, CEA conducted new Czochralski crystal growth simulations. The objective was to grow a 30 kg silicon ingot with a resistivity of 1.6 ohm per cm at the seed side. But how is the ingot realized or pulled out? Well, the pulling started with the load of the crucible, with the addition of 3.5 kg of the recycled silicon, followed by the electronic-grade silicon and finally the phosphorus dopants. A calculation was performed for each ingot to determine the exact amount of phosphorus to add, which would compensate for the high boron concentration present in the recycled feedstock. In total, 3 CZ ingots of 30 kg were pulled by CEA using this novel feedstock. For the last 2 ingots, blending was conducted with respectively 11% and 12% of recycled silicon and 89% or 88% of electronic-grade silicon. The last ingot of 30 kg was pulled free of dislocations. The resistivity varies in this ingot between 1.6 ohm per centimeter at the head of the ingot and 0.5 ohm per centimeter at the tail end. This meets the resistivity and type objectives compatible with the manufacture of heterojunction solar cells on the CEA pilot line. For the first time, using a remarkable blending rate with 12% of high-purity recycled silicon. These results achieved by the Reselex team already represent an important milestone. And now that the squaring and wafering of the ingot have been performed, the solar cell performance will be evaluated. Stay tuned and do not miss the next steps.